Alright, let's go through the sample test here. Determine what one change would be needed for a definition to make a function. Well, if it's not a function, if it doesn't pass the vertical line test. So are there 2 points over the top of each other? If they're going to be over the top of each other, they're going to have the same x. So the x is going to a 5 and to a 2. So to make it a function, I'm either going to have to get rid of 7,5 or get rid of 7,2 or change the 5 to a 2 or the 2 to a 5. So I'll just make f of x, I'll change it by saying let's just get rid of the 7,5 and go on with negative 4, 2, 5, 3, and 7, 2. I got rid of the 7,5. So now it's a function. Okay. Number 2. If the following is not a function, give evidence that demonstrates why it is not. Okay. So for all of these x's, there's only one y. There isn't a value for at minus 4, but there is all the way up to 0, or this line, and then there's a value here but not here, so that's okay, and then this is okay. So it is a function. If it wasn't, if that circle was filled in, then I would say it doesn't pass the vertical line test at 0 because it had two y values for that same x value of 0. But this one is a function because it passes the vertical line test. Okay, number 3. Number 3 says, let me zoom in a little bit because that's kind of small writing here. Number 3 says, find the domain of each of the following. Well, the first one, we have a square root, and the square root can never be of a negative. It can be 0 or positive, so I'm going to write that. 6 minus 3x has to be 0 or greater than 0. So if I subtract 6 from both sides, I get, if I divide both sides by negative 3, dividing by negative, I got to flip it. Negative 3, that make it plus 2. And so the domain of y here is here several ways to do it. From x is smaller than or equal to 2, so from negative infinity up to 2, including the 2. Or I could have written it all x such that x is less than or equal to 2. Or I can say all reals less than or equal to 2. So in words, in a set notation, in interval notation. Okay. F of x in problem 1 above. Problem 1 above, f of x, its domain is just the x values. 7, negative 4, 5. And I don't repeat the 7 because I've already said it's in there, so that's probably easiest to do that in set notation. 7, negative 4, and 5. It's not from negative 4 to 7 because there's no numbers in between, so that's probably the easiest way to do the domain of f of x. And then for v of x, so we have x squared minus 16 over x squared minus 36. Well, I have division, and the only thing that would cause problem is division by 0, so I don't want x squared minus 36 to equal 0. I don't want it to do that. So if I add 36 to both sides, I don't want x squared to equal 36, which means I don't want x to equal plus or minus 6. So the domain of v of x is all reals except plus or minus 6. Set notation, all x such that x is not equal to plus or minus 6. Interval notation, it would be from negative infinity up to negative 6, not including it, or from negative 6 to positive 6, or from positive 6 to infinity. There's interval notations, set notation, and description. Number 4. Let's see, get it there so you can see it. I hope you could have signed it. I'll move that back down so you can look at that for a sec. May have gone off the page there on that one. Okay, so now let's do this one. Zooming in, I'm struggling here a little bit keeping it all on the screen, but I'll try it right there. Okay, find the range of this function. So the range is the y values, so the range of m of x, it goes from a low value of negative, and it said the grid is all ones, so that's from negative 3 all the way up to about 3.3. So in interval notation I can say it goes from negative 3, including negative 3, up to, and I'm not really sure what that number is, I'll say it includes 3.3, but you could have an open saying, I don't know, but it's not an open. It goes to some definite number, but I'm not sure what it is. You could say all reals between negative 3 and positive 3.3, or whatever you decided that was, 3.25 or something. Okay? Find the intercepts. Now I would expect you then to list the x-intercepts, which that is not a point. It does cross right there, which looks like about 0.25 maybe. Approximately 0.25. Again, intercepts are points. Crosses again at about 2.5. Approximately 2.5. And looks like it crosses again at 4.2. Approximately 4.2. And the y-intercepts, looks like there's only one, and it looks like it's about 0.9. Approximately 0.9. Evaluate m at 0. So this says, what's the y value when x is 0? Well, that's 0.9, approximately 0.9. Evaluate m of negative 2. Negative 1, negative 2 looks like about 1.5. It's approximately 1.5. The y value at x equals negative 2. Okay, are we still on the screen? Yes. Find the local maximums. So a highest place in its neighborhood. Well, that doesn't have the highest place, so I can't call that a maximum. Highest place, maximum, that's a low spot. There's a high spot right there. It looks like about, the local maximum looks like it's approximately 3.3 at x equal 123.3. Local minimums, that's low spot. This is a low spot, but it's not there and there's not stuff on both sides. There's a low spot here. This is the bottom, we know this, and it's a low from this side, but we don't know if it's low from the other side, so we can't call that one. Just this one. And so it looks like it's -2, approximately -2 at x equal 1.5-ish. Absolute maximum. Well, that's this place. That's the highest place for this whole thing. And that looks like it's approximately 3.3 at x equal 3.3. And absolute minimum, the very lowest place, that's -3 at x equal 1, 2, 3, 4.6, it looks like. And that's page 1.